Okay, a brand new day, a brand new season. You notice I'm wearing my Bhutan robe. Uh, this is a real Bhutan robe. They really wear this. Because it's a new season, we had the equinox. We're now officially out of summer. Of course, that's an arbitrary, it worked out perfectly this year. So sometimes there's good news, even in the weather. Well, we've been looking higher than the weather. That is the first place to look. If you're looking up, you will see birds, butterflies, and clouds. You will see the clouds come and go. We call that climate because it varies what you're going to see throughout the year, but it is a yearly cycle. Wish to talk about cycles today. This is grade school stuff, but we're in Tunis. And so we're going to be looking at these things with brand new eyes. Because now you know every time you see a circle, you're seeing the number 2. And the remarkable fact that we're going to get into today, again, is that when you see a sphere, you see the number 2 also. Well, it's in Wikipedia. I'm not making any of this up. No, what I've made up is yet to come. Well, right now. You've heard of a dimension. There's 4 of them that we know of pretty well. Albert got us to the 4th dimension, but you can trace that back to Maxwell's electrodynamic formulae. 4D was used for that, but that was the first use of 4D, which had just been discovered as a geometry. It is as a valid geometry. 4D and the study of polytopes, which would be polygons in the 4th dimension, that has been studied a long time. But what Albert did that Maxwell really couldn't do because he wasn't addressing the same direction. You see, Maxwell got us inside. Albert got us out. And we're all about out here. We're not too interested in, although, solving the quantum paradox system, you'd have to say I've looked in. Yes. Well, because you need to in order to understand out. You find that out as you go out. And when you get to the point of the Big Bang, you join up with a particle physicist. Oh, absolutely yes. Oh, these Big Bangers are not just talking about particles and quantum flux because they're deluded. Quite the contrary, they know what they're doing. There is a connection between in and out. But what I've discovered is that's the actual definition of the axis of 2p space. And you notice that's not a D. I discovered 2p space. And I only discovered that for myself, about 3 weeks ago. So this really has been a progress, as you would expect in something newly discovered. Well, I'm going back, in the same boat. It's like, let's get back to where we were last week and keep going from there. You can't stop if it's going this way. It's like an orgasm, but you can die of it because you won't get enough sleep. Because you'll be awoken. Oh, I've been awoken many times. I've had to come to the computer just butt naked and just try and start typing and then go back to bed and try to get warm. Oh, I wake up and I have to get out of bed before I even pee. This is just a strange time in a man's life. When he's just think of it this way. I'm just learning so much, I feel great. That's really what it's like. You just feel, you don't want this to stop. It's never supposed to stop. Well, that's why I use the big O word. Which, I suppose, oh God, is that controversial too? Well, we're all doomed. Oh, well, then I should just get a big zipper attachment. I'd like my first tattoo. Make a big zipper. Start here at this jowl line. I want a big Bluejeans zipper, like magnified 100 times. It goes right across my lips. Nah, dude, I want it all. I'm gonna have my teeth painted so when I smile, it'll look like a penis is coming out of the zipper. I hope that's not objectionable. If I get my tattoo that way. Or you know what? I'll have a tattoo of Donald Trump's face looking out, and guess where his mouth is in this butt, full scale, both sides, all the way down to the goodie land to get it all. So if I bend over like Jim Carrey and forget that my pants will drop and I'm not wearing underwear, I'm going commando, and you see my tattoo for the first time, you'll see Donald Trump's face with his mouth literally where my dirt chute is. Wouldn't that be something? And I have the zipper over half my face that covers my mouth so that it looks like my face is zippered shut. So I can't use my mouth, and the only way I can speak is like Jim Carrey. Only maybe not commando. That's only once. In fact, I would want a jock strap with a V shape coming up so you'd still have full exposure of the crack. But you don't need to see my webbles. Not from behind. Only my wives get to see that shot. I mean, should they have desired? I'm sure I could, never mind. Why? Well, you should know your mate for all eternity, shouldn't you? As long as you get her permission first, otherwise there's an eternity of never that. Which you better believe it. No, you're not. Oh, God, I could tell stories of what my friends have told me. This just, I'm a Presbyterian. I'm a Scottish Presbyterian in the good sense. I know. Well, we're as rare as hen's teeth. I know. That's where we get that expression from. Rare as hen's teeth. You're looking at a hen's tooth. There, you just learned a foreign expression. That's from Golfland, where I get many of my terms. I do a lot of stuff from Caddyshack. I've told you, I gave in when I had enlightenment on my vacation in September. This is September. My vacation in July. Well, I am on vacation. Well, this is sabbatical. You vacation in the privacy of your own home is what that means. You're not supposed to leave your home on Sabbath. You stay where you are. You're going to need to because all the lights are going to be out. There's not going to be any fire. There's no light bulbs. Could you imagine if I ran for mayor? This could actually be done, theoretically. I could run for mayor on the ticket on the Lunar Sabbath once a month for 3 days in a row while there's a new moon. No lights anywhere. There's not going to be any lights that come on after dark in the city of Chico for 3 days in a row. We would become the focus of attention of national support in the way of grants, new programs opening up, because we would pronounce to all the world the reason we make this sacrifice. And it's going to make us a better people, and that's true. We can suffer through 3 nights of no lights in Chico. You know why? you'll see the stars for the first time. Maybe for the first time. But this city would be on the map. It'd be bigger than Rotterdam. It's just a little vegetable burg right now, with a cheap-ass little educational center that I love. I would defend that, I think, against invaders. No, I live here now. I talk with a ridiculous mouth, you know. I'm old and Scottish Presbyterian, I already told you. So that means cranky. If I'm not actually, you know, wacko, then I'm just cranky. Because it's tough to be intelligent among those people or anybody who's organized. You're always going to stand out like the cancerous thumb. And so I did, and I'm proud of it. I was excommunicated. That's one reason why I think I've been entitled to wear this robe, I might say, right now. Yes, I earned this. I earned my stripes. Oh, well, that actually has two meanings. You gotta be careful when you start giving yourself awards, because there's another column that's being filled in at least as quickly. Oh, he's gonna get a couple of cracks for that. Oh, how many does he have of those? Oh, I don't know. If a human being's gonna be able to stand that beating. No, you don't usually brag about that. It's much nicer to count your medals when you're among your buddies. We don't gather around the fire on the cold nights with our sherry and elect to talk about our sins that we know are going to be locked up maybe horribly for long periods of time in quick succession, which won't appear quick since it's on the order scale of time that you won't make it through. Yeah, and then your medals will be turned over to whoever survives you. Because you won't need all that wealth anymore, will you? You're rotting in some dungeon. Not much science. Okay. So you did hear me say 2P, which is certainly not 2D. So what's the difference between 2D and 2P? Whenever I remember, this is recent to me as well. For at least 2 months I was saying 2D. Well, no, forever before 2 months ago I was saying 2D. In fact, it was only within the past 3 weeks that I changed it. I had been looking for this word. I was saying that this is not geometry, it's morphology. And I realized that's kind of ridiculous. Morphology is a superclass term, but geometry, I felt, needed further explanation on what does that mean. And basically discovered that it only has ever had one meaning. In other words, there are not kinds of geometry in the sense of more than one. There are, of course, kinds of geometry, but there are not kinds of geometry. There's only one geometry. But then when you go to get really nitty-picky and just force out the actual definition, it turns out that there is something very specific that defines what geometry is. And you might be surprised to hear this said the way I'm going to say it. The definition of geometry, the way it has always been used to the present day, has meant ever and always exactly one thing, but when you say what it is, I think you must have a question, and so this is your exam question. Try to answer this before I tell you. In 1, 2, 3, or 4 words, define geometry. Here, there's actually numerous right answers. But they're all the same, and so listen very carefully to all the right answers of what is geometry. Until my discovery. We're leading up to my discovery. This is what you need to know, so you'll know what I did to fix it. And the objective here is to find a flaw in the system. But this is the basis of science itself. Geometry are the following things that are synonymous. There are footnotes to each one because, of course, there wouldn't be a separate word for each one if they were absolutely synonymous. Science doesn't work that way. We don't like synonyms. Because then why don't you just have one word then if it's a synonym? Because they're not exact synonyms. That's right. But you do need to be careful the distinctions. But I am telling you to take my word for it that the following definitions of geometry, period, not types of it, but how many of them there are. There is one geometry currently. It is the line. It is the number system. Do you need to hear more? I trow not. And those two things have been proved in my lifetime to be exactly the same thing. There is a footnote because why would there be two words for the same thing? The line is an object, and the number system is the natural metric of the space. You should know all these terms by now. Oh, and I just ran out of fluids. 40 seconds this time. I'm wearing my robe, I'll run. So it's fair to say, since the line, which is an object, and the number system are inseparable. They are, in that sense, the same thing. The difference between the bare geometric line, geometry does not use numbers. But you see, geometry is numbers. Each line that you draw represents the entire number system that we use. When you make 3 of those to make a triangle, you could say a lot of things about that triangle, and the Greeks certainly did, but you must recognize the fact that you began with a line. And it is taken until the 20th century. John Horton Conway discovered this quite a while ago. But we are contemporaries, and he discovered this in my lifetime. But it wasn't this millennium. It was the 20th century, the one preceding this. Because he defined what the number is, for the first time, he actually accomplished that amazing feat. One of the goals of mathematical science was to define the number that would help. He did it, and it's exactly the line. It's exactly, it numerically defines the line, the straight line. It does more than that, though. Because he was able to capture the entire number system of the line, he captured all the infinities. You would have to do that. There are basically an infinity of infinities of irrational numbers on the straight line. And so I want to, the reason I expanded on that, a little off topic it seems, is because in 2p space, the number system uses the same numbers that we're familiar with from the line, but without any of the irrational numbers. They don't exist in multiplicative space. And the universe runs on multiplicative algebra, not linear algebra. That's the difference between my discovery, which is that multiplicative space is spherical space with its own number system. That is the mothership from which our linear algebra detached as a UFO craft, and now we need to get back to mothership because we're just a little toy. Our linear algebra is the toy version of what the universe uses for her geometry and her number system. We use 1D numbers because that's the derivative of the actual numbers, the numbers that the universe uses. We use the derivative of that, and that defines the calculus, which is the solution to spherical space. We need to rationalize the sphere. That's what this does. It turns out the sphere is already rational. It's in fact the number 1. This replaces and in fact inverts the linear system that we use, which means that we have to use the radius of a circle to define the circle. And then when we extend that, we extend it incorrectly with a third line to make a third part of a linear system. And then we make the basis of our numeric calculations the radius of the sphere. In this geometry, the radius of the sphere is exactly known, but it's exactly known, that is the radius of any sphere, the radius of the original sphere, without any numbers or anything else, just the geometry of the sphere. The radius of that sphere can be computed to the exact same degree, which means we're talking about a proportional relationship. When you say that you can measure something now in 2p space, because we're limited in the way we can express what's happening in 2p, this is physical space now. To describe what's happening in physical space, we literally cannot do that, except by saying something in 2 ways. That's a very strange thing to be able to say, but let me show you an example right here. That's a preface to what I need to say now. We're used to thinking of the radius of a sphere as being 1, because 1 is a magic number, and so you want it for your linear system. It is where 1 comes from our point of view. Actually, that is a derivative 1 that's descended by the pure calculus derivative. This is the geometric derivative. To get our 1, it's the derivative of the 2p1. That 1 is the sphere. And so there is a relationship between our 1 and the 2p1. They don't have the same role in their respective spaces. 1 is the first counting number, because 0 is the Archimedean balance point of the add function, which is the definition of the line, is add. It's the space operator for the metric that occurs naturally on the line when you have an Archimedean balance point, which for the line is 0 on add. In 2p space, the 1 is not that 1. In fact, the 0 in 1d space would have to be the derivative of the 0 in 2p space. There is a peculiar way that you can define that exact 0 in 2p space. It would be the imaginary number, because there is no linear 0 in 2p space. There couldn't be, because that's the Archimedean balance point. That you could say that's a derivative of the 2p0. That's the way to start. What is the equivalent 0 in 2p space? The 0, you may know, is the additive identity. Now you got it. What's the multiplicative identity? It's 1. Because it does not affect the space operator. The space operator for the line is add. The space operator for the sphere is proportionality, which is a function of multiplication. It's restricted multiplication, which is miraculous, because it simplifies everything in math. You lose the number 0, but there has to be an equivalent 0. So you might think of the entire number system as being bumped up diagonally, which means you're going to lose 1. So all the numbers work in the next space. When you integrate it, it's an integral relationship. The numbers have to integrate to the higher order version of themselves. They do so very naturally. We think. There's no reason not to think so. This actually works. In other words, it works with our numbers. But its numbers are actually not composed as our numbers. Our numbers are composed from one number on the line. These numbers are composed with what we would call two numbers. And they're in multiplicative relationship, but together they define the sphere. And they define that as the number 1. That's an amazing thing, and let me show you how this works geometrically so you can convince yourself of it right now. Look at the sphere. That's all we need, is just a sphere. You can see it with me. The geometer immediately knows where to look. The center. And we have defined the center of that sphere. Now, what is that numerically? That is the imaginary number. You might think of it as being linear 0 because, for the explicit reason that linear number 0 explicitly does not exist in this space. It falls off the end as the delta that you discard, the same way you discard the scalar result of a derivative, because it's useless to you. You do the same thing on the integral. You do have to drop something, because it's an irrational operation. You're going to have to lose something to get your precision. That's how you do it. That's where you throw the meat overboard. Because you can't cut off enough to measure a circle. You can't measure a curve, ever. It's irrational. It's an irrational relationship. Well, what if you step up to where you got the irrational relationship from, adopt its number system? The integral number system is 2p. And I've proved how that you actually can, that's how we get two linear numbers from circular space. On sine and cosine, this is how we do it. And when you do the calculus derivative, you're getting basically a rate, right? Or a slope, however you look at it, out of a curve. You're linearizing the curve at that point. Because That's where your computable numbers live. They don't live on the curve. Well, we need the computable numbers in curved space. And so we start with the sphere. That's what the universe does. That's been proved. That's called the Big Bang. And that theory is absolutely right at its core. The basis of the Big Bang is one of the most amazing discoveries in the history of science. But it is interesting they lead it back to a linear point, just as they do with the black hole. Well, they're both singularities. That singularity is the imaginary number in 2p space. In other words, they've imagined the point at which the Big Bang occurred. It basically implies that it never occurred. In other words, you could say that the Big Bang has been disproved, but you would be very hasty in doing so. Just because there's a hairball at the middle of the black hole, I discovered the supermassive black hairball, the supermassive black hairy thing. Black holes have hair. You may have read that. Top-notch scientists say it unabashedly now. They're sick and tired of being ashamed of it. They can't get rid of it now. There's hair. Black holes have hair. I can't make this shit up, baby. And so I have discovered the hairball. Well, if it has hair, then it can lick the hair. And then it goes to the center, and where they think is a singularity, where the poor kitty cat's stomach turns inside out, that's pretty nasty. You know, you gotta hate those Princeton and Cambridge boys for saying that kind of shit about cats all the time. What do you got against cats, you faggot foreigners? They know I'm kidding, but I wouldn't say that in an Irish pub. Actually, I would, but only if I knew they were like, nah, the American can do no wrong. He's a comedian. Let him say what he wants about anything. I love him. Well, you know, that's what you hope for all the time. Because I'm not malicious. I am a putty tat. I am a fucking pookie cat. Kids love me. Fucking animals love me, except I do have an aversion to dogs. I just don't like dogs. I owned a dog, although really my parents owned the motherfucking dog. I don't like dogs. I'm sorry. I've met a lot of dogs that I've liked. I've let them lick me. I mean, the owners don't even know what to do because I'm just like obviously getting into it. The dog's practically making love to me. I don't like freak out and try to get out of the house. I let it go on. You know, everyone has to stop the leg hump. And I think everyone, you don't think it's going to happen to you, but here comes the dog, it looks normal, and oh, no, it's not. Oh, hey there. And so you don't trust them. I mean, it's not that. I mean, they're all right. Well, people love them, so of course I do. I'm a person, for fuck's sake. No, you know, there's reasons why we show these strong preferences. It's because we're imbalanced. You're just saying, it's a cry for help. I hate cats. You know, I never condemn people who say that. You know, you want to hate them back. It's like, what are you, out of your mind? Are you retarded? You want to use some nasty word right away. Oh, you hate cats, and you had to say that out loud. Well, they have places in Oregon for people like you. You don't. I mean, I don't. No expression change, maybe a wry smile, just shaking my head in a non-threatening way, because I can't help but shake my head right now, praying the person doesn't notice. I think they're insane, out of their minds, retarded, probably criminal. I'm never going to talk to this person again. You don't like cats? No, you know, neither do I, and I'm looking for the exits. Now, those kitty cats, you know, they shed, right? That's the bad thing. Oh, I gotta take a whiz. See you later, buddy. Hey, where you going? You don't like what I said about cats? That's what you don't want. So it is interesting, this 2p space is simply multiplicative space. It's just kind of miraculous that it makes a sphere the way we've shown that it does. So you could say it either way, inside out, the sphere was already there, and therefore the number system, of course it's there. Well, someone still has to discover it. And so it took the work of Max Planck back in 1900, practically the New Year's Day of the new century, leaving the brutal industrial 19th century. I think McKinley had just been assassinated here in the Oval Office. Just murdered in cold blood by some anti-whatever party McKinley was. But they did name a mountain in Alaska after him. I think it's in Alaska, right? Is that Mount McKinley? Okay, whatever. But Max Planck did make what I have said, and I'll stand by it in context. Max Planck made the greatest discovery in the history of physics. At least certainly to that day. And we look back, I mean, I don't know why people aren't more excited and just, I don't know, but Max Planck doesn't really seem to get a lot of credit for what he discovered. Do you know what Max Planck discovered? Has a direct impact on 2p geometry. He's the father of 2p geometry. I merely am following up on his discovery. And Emmy Noether's, another Nobel Prize winner, whom Albert Einstein adored, and for good reason, so do I. I use her theory, and I use Max Planck's discovery to solve Einstein's, well, to explain Einstein's discoveries. Without the use of tensor calculus or hyperbolic space, just explain what the fuck he did in real geometry that we can understand. Well, that begins with the sphere, not the line. That's the secret. You can't understand celestial mechanics with your straight lines. It's never been done. It always leads to calculus because you can't solve the mystery of the sphere. Well, I did because somebody had to do it. You change objects from your accursed straight line, which is not accursed, but think of it that way now. I'm going to show you where those straight lines come right back. But they come back in a way, the whole thing, the 3D grid, yes. Oh, it's in spherical space. We can't afford to lose that. It's in there. You just need to integrate your lines into the natural space and treat your system as the derivative system, which it is, and start using the real system. You can switch there the same system. Because the 2p system contains 1D. It contains all the D's, 1, 2, and 3. I'll give you a secret, just discovered now. Well, it's just an aspect of this that's worth saying. It completely explains Albert Einstein's discovery of 4D. Because 4D has enough of the same characteristics as 4p to be able to get the solution that he got. But his is the derivative solution using sticks. And his imaginary stick, with the help of 4 tensor calculus, which it took him 10 years to learn this algebra, children, he practically invented this form of tensor calculus on his own to get this analytically. He fucking did it. But it's not the best of the two answers. There are two answers, of course. but not until you realize there's a mothership number system from which yours is descended by the natural descent of the calculus derivative. All we need to do is obey the fundamental principle of algebra, which is basically to obey what the fucking calculus tells you to do. What does it tell you to do? You have a derivative space. You have an integral space. Can we be a little more specific? The derivative space is 1D. But you have two numbers in curved space. Whether it's spherical or circular, you have two numbers for anything other than a straight line. Anything except an absolutely straight line, which is quite unique, is even three-dimensionally unique. After that, it's ambiguous, but you can use an imaginary one if you dare, since our vision is split, and so's the universe. So you can put in one imaginary vector more, but you will never, ever put in a fifth. And yet we have a transdimensional algebra. What does that imply? You want the transdimensional solution. How are you going to get it? You can't by building with sticks. Albert Einstein proved that the hard way. The greatest achievement in the history of the human mind. You'd have to say in its class or category of its type. But it's hypercubes, and all we need to do is integrate his solution into an object. In other words, you integrate the algebra, if you could do that. Turns out you can. It's been done for 2D imaginary numbers, which you need to get rid of. When you have an imaginary number, you have an imaginary space. And it will stay imaginary, and that was the curse of the complex numbers. It's not a curse for analysts. It's a gift, but it's useless in heavenly science, and a pain in the neck on earth, because it's the incorrect geometry. It's an attempt to get to 2D the right way, but only Albert could pull that double rope trick. That could only be done once he found the way to do it. It's by making two errors knowingly. But it is possible to undo that knot and get the right answer, the integral answer. We've been using the derivative number system, the lines, the linear numbers, to get spherical results. No wonder it's a nightmare, leading nowhere near understanding. Although, even with the mistaken number system, it is remarkable the correct deductions that have been made, both in astrophysics and in microphysics, basically quantum harmonics. Oh, these scientists are no dummies. They know when they're onto a good thing. But would they recognize if they could get on to something beyond their wildest dreams better? I've found that this geometry, simply by learning it and forcing yourself to define it, leads to intrinsic and fundamental insights into how the universe actually does things. And then it leads in every direction on discovery vectors. As far as I am somewhat emotionally, prejudicially saying is the case, it feels that way. Well, let's start at the beginning then. What does this do for us? If you're willing to take the step to conceptualize space spherically, then you're now able to proceed with a guide, which I am, as to what it means. That would help, wouldn't it? The concept of meaning that we are dealing with is well known to us, but you need to be aware of something about what this kind of understanding supplies. And I've drawn that boundary line very carefully, so I'm just going to silently nod my head at you. We have named it, okay? So this is where we leave behind earthly science. We are now in a different realm of science completely. I call it synthetic geometry. It is a phase in the great cycle of science. Science is a big thing. It has phases. And near the end of one cycle is what is called synthesis, or the synthetic stage. It's absolutely required by logic. It would have to exist. This phase, where understanding is achieved. Understanding is somewhat difficult to define, and yet we all know what it is. How can it be both? Many things are kind of like this. We all think we know what it is, but then we all have trouble defining what it is. And so we just kind of nod each other. We all know what it is. Well, in science, actually, it's not a nuisance. It's a necessity and an honor, and it can be a privilege and honor, but you have to do it anyway. You have to actually take the motherfucker apart. You're just going to have to take all the screws out and examine every goddamn last little thing. Or you won't actually know, you see. So we have predecessors who have done an amazing amount of work for us. The first one I need to mention, because this is germane to our topic, trust me. John Horton Conway proved something I needed to be able to prove, and he enabled me to prove it. I needed to know for sure if that line is actually a programmable object. And it is. But that is so fundamental that it actually defines a lot of things that easily, it's a simple definition for a lot of things, is that line rules everything. That line is kind of scary in its power. Because it's all it is an imaginary object, is a straight line. But then you can write books and books and books of worthwhile, true statements, things worth knowing about the line. I mean, if you were to say 2,000 years ago or 2,500 years ago, just dreaming about this, the future, you're a Greek or something near the Greeks, and and you're saying, Elmer, or whatever a good Greek name would be, the goats are baying in the distance. The dogs are minding them, so we have a moment to philosophize. And maybe we smoke some hash that we got from the Silk Road traders. And so now we're higher than Gilligan's freaking kite. And just thinking about things, And one of us ventures, I'll bet that with these 3 straight lines that Anapagoras discovered, I mean, that's pretty cool stuff, wouldn't you agree? Oh, I agree. I agree, Iliad, which I think is a Greek name. Iliad and Odyssey, those are their names. The shepherd men who are the dogs attending the goats. So they're talking about these sorts of things because they're Greeks or Proto-Greeks, Scythians or whatever. Maybe even Chinese or Polynesian or Native American, North or South, or Africans. Who cares? Or as my mother would say, maybe the polka dotted eye. But let's finish the story. What was it? Oh yeah. So when you have a sphere and you begin with a sphere and you just start thinking in terms of the sphere, and you have some instruction because your forebears were very clever, and you know the sphere represents two numbers, and that any point on the surface, which is the sphere, is the surface only. That's why it's two, not three. It's just longitude and latitude. Just longitude and latitude. Isn't that amazing? Just two numbers defines anywhere on a sphere. Longitude and latitude. Well, incorrect. Not completely. No, there's the North Pole and the South Pole. And if both of them don't fuck you up, you take precautions against the poles not fucking you up, one of them will fuck you up anyway. So you'll be lucky if you accidentally remember which pole is which. But they'll both fuck you up. And for that reason, men discovered in the 19th century to solve that problem, because with your two numbers, latitude and longitude, you're going to be able to fly a jet upside down and just crash and kill the pilot. You'll never even know what the fuck happened because you're a stupid mathematician. It's called gimbal lock. And all that happened in a simulation flight. It was totally unexpected, but they should have known. But it had been a real, they would have turned upside down because they crossed the equator or some damn shit. Nobody noticed that inverted the fucking and caused gimbal lock, and so it suddenly thought that it was flying upside down from the way it actually should be, and that's not going to last long. Because it has to do a really difficult turn now to make that happen, for one thing. Probably knocked the pilot out with the G-force of this sudden turn to flip upside down and go back through hyperspace, I guess, because nobody knows their math back in Houston. Or, I mean, lying, whatever, wherever they take off from. So it was learned by the clever mind of man, using his blueprinted intelligence to figure this shit out. All you need to do is go up one linear dimension. And William Rowan Hamilton, oh boy. William Rowan Hamilton, the astronomer royal in Ireland, worked right out of Dublin, top guy in his day, great, one of the great mathematicians of all time, invented a 4D rotational system that removes gimbal lock. In other words, he solved the problem in 3D by going up one dimension because it gives you an extra degree of freedom. And that extra degree of freedom is helpful to avoid gimbal lock, which is basically the equivalent of division by zero in geometry. And it will crash your plane instantly or kill your astronauts on their lunar descent, which almost happened because of gimbal lock. But they had a window, so they reset it in time to land, and they got back to Earth. But gimbal lock is nothing to make fun of, but it is an inherent weakness of our linear system that shows up in 3D space. And the only way to get rid of this horrendous error in our math system is to bump up to 4D with that's why it's quat. That means four in Latin, I think. Quaternion. That's been absorbed by geometric algebra. So we don't need quaternion algebra anymore. But nobody's ever thought of spherical algebra. A remarkable fact, but as I've taken pains to point out, there are very valid reasons, convincing reasons, why nobody ever saw this. Which does toot my own horn, but I'll tell you what, I was driven to get this answer. Which shows bias, by the way. You should be suspicious now. I don't think you... I hope you're not suspicious, but we'll have more about how profound this is when I complete the sentence that I began several dozen minutes ago of what, when you have a sphere and you try to get to the center, can you reach it? And the answer is no. For the same reason you can't reach infinity going out. They cancel to make the sphere. The reason the universe exists is because the imaginary number, which is a 2D imaginary number, it's infinity over 1 times 1 over infinity. And that cancels to 1. But you see, that is 0 in 2p space. The sphere is 0. Even though it's the number 1 that we would interpret the number 1. That is, the surface of the sphere is 1. It's the number 1. It's a relational 1. It's 1 over 1 colon 1 over 1. And colon means multiply. But you should put colon because it's restricted multiplication. Although it simply is the multiply operation, the colon indicates that the two components are a setup on the number 1. Because in a 2D number, the only thing that changes is the numerator of this one and the denominator of this one. They change to the same number, and the first counting number is 2, and the next one is 3, and the next one is 4, and the next one is 5. I'm not positive how certain we are of the linear sequence there. They are rational numbers, and the components of these two rational numbers, you can think of them as fractions, but one of the fractions is over 1. So one of the components is always a whole number. But which whole numbers? Max Planck proved that it begins with 2, and he proved that this exists on a harmonic. But I'm not sure if it's been shown that the next one is 3. I had always assumed so, but I have read some in-depth, I guess you would say, discussion of that, where something else was suggested indirectly. It just came to my mind. It might not be 2, 3, 4. The first counting number is 2, but it's also 1/2. Because as you go out from the surface of the sphere, you go out by 2, which is a quantum jump. It's the jump from 1 to 2. There's nothing in between. So there's your electron orbit. You could think of it that way, as from the surface of a sphere. That's perfectly accurate. It's just an example for your visualization. It's not to prove that that's the electron orbit. I'm just saying you're going out from a geometrically defined sphere, which is a surface. But as you go out, simultaneously you go in. And the other number describes that. Do you know what that number is going in? It's towards 0, but 0 doesn't exist. But that 2D center does exist. It's 1 over infinity. So whether you say that that exists or not is really kind of an existential question, which deserves to be answered both ways. We'll come back to that. But that center is very interesting and highly explanatory when it's looked at rationally and logically using pure geometry, pure relationship. That's what this is pure relational logic. This is the relational form. It's the integral form. So it contains a higher order of phenomena that are now integrated. Basically, everything that we saw as split before in two will become one under this geometry. It's a unifier. And actually, the goal here is to unify time and space in this sphere. I found it. We're getting there. But actually, there are some steps you need to know, like the rotation. We haven't talked about rotation yet. That introduces motion, which is equivalent with the introduction of energy, which is therefore the introduction of time. But it lives on this equator in a non-spatial way. And that has a name. It's called the event space. But to call it space, you're going to have to split your mind so that it's either space or it's not space. Because an event does not occur in space. It occurs in what is not space. That's what an event is in this system. It's the thing that's not spatial. But we can define the static sphere. That is the sphere we just defined, but it's not rotating. So it doesn't have a ring. So it doesn't really exist, because every sphere in the universe has a ring, defined as its circle of frequency, or circle of energy, or circle of motion. It's the circle of angular momentum, is what it is. That's the best name. A lot of things tend to become synonymous at this level. But that circle we call the equator of the Earth, or the orbital plane of the planets, or the electron shell. But the electron itself, that is peculiar. It is a perfect sphere that's been measured within the past, within the past decade. And they can't say perfect, they're not allowed to, because they know perfectly well nothing's perfect in a quantum world. But it is perfect to the quantum limit. That's exactly what an electron is. It's the definition of a sphere to the quantum limit. The smallest something can be and still be something is basically an electron. But then there is the proton. Proton doesn't behave at all like an electron. It bends space, apparently. Perhaps. That is certainly the right way to say it currently. I assume that that is true. I always have. But I think you're going to find with me as we progress into this, it is possible to see this correctly without seeing space bending. It will come to that as we're able to integrate our understanding into the higher order understanding level. That's what this is. This is evolution in action. To the degree that you can understand and master this, which is simply to understand it, it will master you. It's like finding Aladdin's lamp. That's a little over an hour, my longest lecture in a long time. I hope you're impressed and I hope you're having fun. We want both. I am impressed and I'm having fun. This is not going to get tedious if I have anything to say about it. I hope that you're starting to share my excitement, because I'm not going to stop being excited about this. I'm going to try to share it, though, so that you can not have to believe me. This is public domain. I don't care who copies this and takes credit for it. You can attach your name to it and get millions of dollars if you want. I'm sure that in a perfect world that would be within reach, as this is it, baby. We'll be back.